So what are the different ways to set up single subject designs? As I said, typically the hallmark of single subject designs is frequent measurement of the subjects and of your target dependent variables. So let's take a look at a couple of examples. So in single subject research, often what happens is measurements are taken on a subject, on one or a small group of subjects over time, and the intervention is applied, taken away, or what have you. The simplest design in single subject research is called an A-B design, where a baseline measure is taken for a period of time before the intervention. So we have some aspect of measurement or performance that's taken over time. So on this chart, what we see here, this line graph, we see that, whatever the measure is, it's a 4 at the baseline. It's measured day 1, day 2, day 3, day 4, day 5. And there's a little bit of variability, but we get an idea of where the person is on this performance measure. That's called phase A. That's the A part. Then an intervention is introduced and the measure is continued to be taken. In a lot of these studies, they measure various things. They don't just take one dependent measure. They have several dependent variables. But again, this would be an example of one. So what we see here is that the person performs around 4 or 5 at the baseline. When the intervention is begun, we see an immediate increase in their performance or in that measure. That's what you would expect to see if the intervention is effective. And that's an A-B design. It allows for us to look at when the intervention is created and then how measures change. Changes in the measure are attributed to the intervention. However, there's some concerns about this, right? If you're looking at one person, maybe the first couple of days they were a little under the weather, and that's why their baseline was low. And maybe the intervention wasn't really the reason then for that improvement, but it's because they were feeling better. So that's always the risk of using small subjects in these types of designs, is that there's always a chance that the measure may not be due to the intervention. It could be due to a carryover effect, maturation, just the fact that the person is getting older or getting more experienced. There could be a learning effect in whatever the measure is that you're taking, and so on. So an A-B design does have low internal validity, and therefore we have to be careful just accepting these changes as true. Now, if it's done on more than one individual or it's repeated with this individual at a later date again, then again, we get a little bit more confidence that the effect is real. The A-B design can be improved in its validity by turning it into an A-B-A design. And what an A-B-A design is we add in another series of measurements where the intervention is then again removed. So an ABA design is where we have a baseline where the intervention is not present. Then we have an intervention where we continue to take measurements. Then we remove the intervention, the training technique or the supplement or whatever it may be, and we continue to measure. This type of measure, if we see that they are at some baseline, a lower measure, they get better when they have the intervention, and then they get lower again when the intervention is removed, gives us greater confidence that the improvement was truly due to the intervention than just due to some other factor. And then you see a whole bunch of other types of examples. You can see ABA, where again is shown in this figure. We can do ABAB, we can do BAB, any combination of these different periods where we do the intervention, remove it, and measure. Again, so there's lots of different types of ways to kind of tweak this design to, again, be more and more confident that the changes in the performance measure are in fact due to the intervention. At times, we may compare different interventions, like one type of training program and then another type of training program. So we can even see AB, CB designs and so on. Frequently, we look at you'll see in the research, a BAB design where the intervention is actually present and then it's removed and then it's applied again. And this is often done when we look at athletes at the end of a season because they're obviously involved in the season, which would be the B phase. Then they go through a period where they are not doing the intervention which would be the A phase. So again, we can look at the effects of detraining in that type of a study design. Another study that can be used in single subject design is what's called the changing criterion design. It isn't as much focused on does the intervention improve performance, but it looks more so at the rate of improvement, how quickly we can bring about a change in some performance measure. So the chart that you see here involves, again, serving speed. So if you have an athlete and your goal is to get them up to able to serve at 170 kilometers per hour, the question might be, how quickly can we get there? So maybe we want to look at this in 5 kilometer per hour increments, and look at how reasonable it is to get a person to that level, how quickly they can reach these different levels of performance. So it's sort of the extension of an ABA design, where phase A is a baseline measurement, and then phase B is where we do an intervention until a performance measure is met. And what that allows us to do is to continually kind of enhance and increase, the challenge of an intervention after we meet a certain goal. So maybe first you say you want to increase serve speed by 2 miles per hour, and then you're going to, once they do, then you're going to increase or change the intervention. And as they remove or reach each baseline measure, we then move up to that's the baseline, and we move to a new intervention. And what it allows us to do is look at how many weeks or days or how much time it may take to move an athlete from one level of performance to another target level of performance. A multiple baseline design is a widely used single subject design. It's better at controlling threats to internal validity. It's appropriate when interventions that you're utilizing cannot be withdrawn within your subjects. And basically what it does, it uses separate A-B designs with multiple independent variables. When they're doing this, so you would have multiple independent variables and multiple parts of your intervention that you're going to be applying to the people. This only works when the dependent measures that you're looking at are independent from one another. So for example, if you wanted to work with a bunch of soccer athletes and improve their dribbling ability, improve their passing ability and their shooting ability, then we can see that those skills are somewhat independent. You couldn't do this with 3 different measures of speed, for instance. And then basically you're going to implement different training parts, different parts of your training program, a soccer training program, over time. So at first, maybe you're looking at dribbling skills and you're going to measure dribbling performance, while you're also measuring passing performance and shooting performance. So while you're doing this intervention of dribbling, you actually see this is where you started the intervention for dribbling. Everybody was pretty solid and similar in their baseline score in these skills. When you start doing the dribbling training, we get an improvement in dribbling skills, but we don't get any change in passing skill or any change in shooting skill, which tells me that we can be pretty confident that the intervention I started improved this, but not the other. So I can be pretty confident that my training did target that specific skill and not all of them, or that there wasn't some other factor that caused me just to improve in all aspects of soccer performance. You then start the second intervention on day 5, which is passing drills. And you see, again, not really any change in the performance in shooting, but we see that passing gets better. Obviously, we're still doing the dribbling intervention, and that continues to improve as well. And then finally, after a couple more weeks, we start doing the shooting skill training, and we then see a fairly quick increase in shooting ability. So again, this allows us to once again look at each of these different training programs, these interventions, but tease out again the effect on these different skills. And that's called a multiple baseline design, because you're taking multiple baselines because you have multiple dependent variables. An alternating treatment design is where you use multiple interventions, different treatments, treatment A, treatment B, and again, look at performance. design really only works if there isn't a lot of carryover effect between the interventions, meaning if you do it today, it doesn't necessarily affect you tomorrow. So the example they give here is fatigue level, and we want to look at two different treatments that help reduce fatigue after a run or after some physical endeavor. They wanted to compare one treatment, which is stretching and hydrotherapy, and then, stretching, the other treatment being hydrotherapy, like a cold bath. And again, so what we see with treatment A, which is the stretching, basically we have them do an exercise, a workout, and we measure their fatigue without any treatment. And we can see that their fatigue level is scored somewhere around 9 or 10 all of those days. And then one day we'll do treatment that's stretching. The next day we do treatment that's hydrotherapy. Then we do stretching again, then hydrotherapy, then stretching, then hydrotherapy. And we measure fatigue levels. And we can see that both treatments seem to improve or decrease fatigue level. However, the hydrotherapy treatment did a better job at doing that. Now, this isn't based on real data necessarily. This is just an example of a type of study. But it shows how we alternated the treatments to try to keep an ability to look at the effect of each one independently from one another and how it affected fatigue. So again, we can see that it allowed us with this subject to look at these different treatments and how they were affected. Now, in these studies, how is data analyzed? We often, because we don't have large numbers of people, we can't use t-tests and ANOVAs and so on. So typically, one of the main ways to evaluate this data is visual inspection. We chart out their performance, like the graphs that we've seen so far, and we look at what the data did. Did it go up? Did it go down? It's often presented in this type of a time series. So what happened when they were under the baseline? What happened when the intervention was started? And what happened to the data? Did things get better? Did the performance get worse? And so on. We also pay attention to the significance or the meaningfulness of the change. If you were measuring range of motion, the ability to move hamstring, flexibility, and we see an improvement of 1%, 1 degree, 2 degrees, that is a change, but that's not a meaningful change to me. That isn't something that clinically is going to matter. So typically we look and inspect the data visually to see if change occurred, and if so, was it a meaningful, clinical change that's going to maybe add to produce some benefit. There are statistical tests that can be used with small data sets. The statistical tests that can be used, though, are different. They aren't ANOVAs and t-tests. They tend to be things like time series analysis tests, split middle techniques, different types of tests of ranks. And they do allow us to still potentially get some evaluation of whether or not there is a statistically significant level of change. And that's usually done by comparing the baseline phase with the intervention phases. Now, I will share these two studies, and they're going to be required reading for this unit. They're both good examples of single study or single subject designs. This first study is an example of an ABA design where, again, there's a baseline first determined without any intervention. Then the intervention is introduced, and we continue to take measurements during this. And then finally, the intervention again is removed. And what these individuals were doing was looking at the use of pre-shot imagery on golf accuracy, the ability to accurately take a full swing and hit the ball at a target. And basically what they were measuring is, how many balls did the subject get within the central part of the target, which is section A1. That's what that is. So without the pre-shot imagery, they on average got two on day one, 2 on day 2. They got 3 the next day, 2 the next day. So fairly consistent, right? Then once the intervention was begun, we saw a jump to 5 and 8 and so on. But again, probably an increase in their performance, especially at the onset of the intervention. And then once the intervention was removed, they weren't allowed to do the pre-shot imagery. Then we see a drop back down to levels, again, similar to before, and so on. So that would be the ABA design. And again, this was just one measure they took. They also, if you take a look at the full study, they looked at how many balls didn't get in the target area as well, with and without the treatment. So it's pretty neat, pretty interesting. The other study that I'm sharing with you as an example is, again, shows the value of single subject designs, because they allow us to go out and get a very specific type of person with a specific condition and look at their performance over time. And this study was interesting. They took a lot of different dependent measures. I'm only sharing 2 of them here. But they basically looked at an individual that was engaged, that has Parkinson's, and they were doing a lot of different functional performance measures, like a 6-minute walk. How far could they go over 6 minutes? How long it took them to get up out of a chair and get moving in a functional manner, and so on, and a whole bunch of different measures, which are, again, interesting and very practical for an individual. And they utilized a BA design. Remember, a BA design is where there is an intervention going on, and then the intervention is removed. So in this individual, what we see is they were undergoing first they were placed into a training program. We can see their baseline measures, or a measure before they started, and we could see immediately an improvement in how far they could walk in the 6 minutes over the 6-week training period. When the training period was ended and they removed that training, we do see a decrease back towards their baseline in their ability to perform the 6-minute walk. When we looked at the timed up and go test, which is where they have to, again, get up, out, and move, so lower times are going to be better. We see a similar, but because here a lower number is better, on the other chart higher is better. We see an improvement very quickly occur 2 weeks, 4 weeks, 6 weeks, and then when we stop training, there's a bit of a carryover where it persists for a little bit, and then they start to drop back down. So again, a way to examine blood flow restriction training on an individual with Parkinson's and so on. So again, I think that's an interesting type and application of this type of research study. Anyway, we've talked about a variety of different experimental design types thus far in this class. Single subject research design is very different than the other ones we've discussed thus far, but still has some really interesting value and application, especially when we are attempting to study very unique individuals with very specific characteristics. These are the articles that I have utilized in this presentation. Some of them are examples of single case or single study research. Others are kind of how-to articles when it comes to designing studies like this. And of course, I still utilized information from the textbook Research Literacy, a primer for understanding and using research.